Okay, so chapter 4 is on arguments. An argument is a sequence of some sentences that are used to imply other sentence or sentences. Maybe more, maybe one. Okay. In argument, hari ni Kai, if you see anybody type in chat tak nampak ke, tak dengar ke, you turn on the mic ya. And awak cakaplah dengan saya because I don't read the chat. Okay. Okay, in argument symbolic form, we write, okay, so we have some sentences S1, S2, SM. So these are sentences S1, S2, SM. This is the arrow that implies other sentences, and the arrow we can have other. I use different M and N because they can be different. The numbers may be different. Okay. And where SI, I from 1 to M, are called premises, and PJ, J1 until N, okay, PJ 1 till N are called conclusion, okay, premises and conclusion, okay. All right, so now, I think if I write down there, saya boleh duduk. It's still right. It's it. Example 4.1. Okay, example 4.1. If it rains, then the road is wet. This whole sentence is S1. Okay, this whole sentence is S1. So we write colon S1. Okay. And then it rains. That's the next sentence. This is S2. Okay. Therefore, this is therefore. This is therefore the road is wet. The road is wet. So this is actually the P1. This is actually the P1, and this is actually this arrow. Okay. So this whole thing, this example can be written as S1, S2, P1. Okay. 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 Where is your reaction? Okay. Okay. This is different. This chapter is much different than before. So make sure you understand the very basic. Okay. Mana pemadam saya tadi? Alright. Papan kecil yang kena padam, habis kena padam. Okay. Oh, I'm in my office. This is my office. Alright. Nak tanya soalan. If you want to say something, go ahead. Senyap sangatlah kelas hari ni. Okay, example 4.2. Example 4.2. If it rains, then the road is wet. This is one whole sentence, yeah? This is one whole sentence. We call it S1. Okay. If the road is wet, then it is slippery. Okay, this is also given as S2. Okay. Now, the road is not slippery. The road is not slippery. S3. Okay. Therefore, when you see the word therefore, then you have the premises, right? So these are all just the conclusion. These are all the premises. Now you have the conclusion. Therefore, the road is not wet. Therefore, the road is not wet. So this is P1. Again, another therefore. Another therefore. So another P. It does not rain. It does not rain, which is a P2. Okay. So from all this, so thus S1, S2, S3, P1, P2. Okay. What I'm doing right now, this is just rewriting the question in symbols. We didn't do anything yet. This is just rewriting the question in symbols. Okay, so this is called a valid argument. This is called a valid argument if S1 and S2 and S3 P1 and P2 in this case is a tautology. It's a tautology. So back to the previous chapter. Yeah. Okay. Now, in general, so S1, S2, SM, P1, P2, Pn is a valid argument if, like this, S1 and S2 and Sn, okay, this P1 and P2 and Pn is a tautology. Okay, so this is just by giving you the definition. We haven't done anything yet. Okay, we'll look at more examples today. Okay, now arguments has many names underneath, the sub-names. I will confirm with you whether we will give this in the final, the list, or whether you have to memorize. Okay, all right. So I will give you more examples. Is this okay? I can erase, right? Okay, okay. I see one, orang Jawa panggil apa? Jempol. One jempol. The good. Okay. One is enough. Okay. Okay. So 4.2 is what we call syllogisms. Syllogisms. Okay, syllogisms. It's exactly like before. Okay, exactly like before. If it rains, then the road is wet. We call it S1. And then it rains, which is S2. Therefore, it is wet. Because there is a therefore, you put P1. Okay, or just only one. Okay, now on another note, we write let P, our sentence is it rains. And Q, the road is wet. Okay, this is back to our earlier chapter, yeah? Back to our earlier chapter, in which when we have a sentence, you write in form of statement, okay? Now, the question is, in symbolic syllogism form, okay, we want to write the question, rewrite in symbols. So if it rains, P. If then means there is a implication, right? When you say in sentence, you say the word if first. But when you write P first, right? Because this is in the middle. So if it rains, then the road is wet. That is the symbol. If it rains, then the road is wet. And then it rains. It rains is just P. It rains is just P. So Q. And sometimes some books they put like that. Okay. If you have implication, P implies Q, and you are given P. Conclusion is Q. This is true. This is the whole validity of syllogism. Okay, remember this. This is the very basic one. If you have P implies Q, and then you are given the P, therefore Q. Okay, all right. Now, in symbolic argument form, okay, this is syllogism form. Argument form is the original that I give just now. We put P implies Q, P, okay? P implies Q, the original definition, yeah? S1, P, S2, therefore Q, right? In symbolic implication form, in symbolic implication form, P implies Q and P. This one, you can do this or you can do bracket. Both are okay. So P implies Q. We want to put one here. And P, that's why many books put like this. P implies Q. And P implies Q. This arrow is under implication form. This arrow is under argument form. Don't get confused. Okay. Now, we can show this is a tautology. How do you show it's a tautology? By the truth table. Okay. So then we can show that this implication is valid. Now, this one, this is very, very famous. This is called modus ponens. I think you have learned this in Form 4, right? Logic? Yes or no? I think, ingat ke tidak, saya tak tahulah. Ada tak? You learn this before? Logic?
Lupa, Doktor.
Ada?
Lupa.
Tak lupa, awak dah tua. It's called modus ponens. Okay. Ada dah satu dah kita kena ingat hari ni. Modus ponens. Now, I give you 2-3 minutes to write a truth table to show it's a tautology. Ni ya. Okay. So when you do P implies Q, you realize you have to remember. Only T implies F is F. Only T implies F is F. Right? Itu je, yang lain semua true. Only T implies F is F. Right? The rest is true. And then the N, what you have to remember, only TT is T. Right? So only TT, so you have to look here and here. And the rest has F, so it's all F. Now for implication back, so this one, okay, implication, only TF is F, right? TT, right? TTT, and then these are all F. When this is F, whatever it is, all T. That's why I can do it quick, right? So you want to do here, implies here, since F, I straight away put T. So this is the trick. All right. Okay, that is modus ponens. Now next example. Okay, before I erase, is it okay? Ding. Okay. Alright. Okay. Now, next example. 4.4. Okay. This is the type of question that you will be given. Prove that the following syllogism is a valid argument. Okay. This is the question. If it rains, then the road is wet. If it rains, then the road is wet. The road is not wet. The road is not wet. Therefore, you see the word therefore, so that is the implication, yeah? Therefore, it does not rain. Okay, so we write in symbolic syllogism form. What do we have? Suppose it rains is a P. The road is wet is a Q. So this is P. The road is wet is Q. Saya tak payah tulis balik ya. The road is Q. The road is not wet. So this is not Q. The road is not wet, not Q. Therefore, does not rain is not P. So in symbolic implication form, we put P implies Q and not Q implies not. This one, you can also write like P implies Q, not Q, not P. You see the difference? This is a comma, and this is this arrow. This is in syllogism form, but implication form, this is an N, and this implication. Okay. Now, how do we prove this? Okay. Okay. All right. How do we prove this? I still have. Okay. Number one, I will write the question. P implies Q. There are many ways to write, but this is one of the ways. Maybe it's a bit different than the, let me see the notes. Okay. This is how I would do it. You know, if P implies Q, the contrapositive is not Q implies not P, right? This is the contrapositive. Okay. Next we have not Q. Okay, this is given. Okay, this is given as, you can put or you don't have to put. What do we call just now? S, yeah? S, right? S1. This is S1. This is S2. Or you can put any way you like. Don't put also is okay. because now I introduce like this, right? Or you can just put down there. But it's normal also to put as 1, 2, 3, 4. Now, this, and then this, what do you get? Not P. And this is because of the modus ponens just now. Modus ponens, I call it MP. All right. So this is how you write the argument. Okay. From here to here is contrapositive. And then this is given. So from here to here, if you have P implies Q, and then you have P, then you get Q. This one, not Q implies not P, and then you have not Q, so you have not P. So this is the result that we want. Yeah, so that is done. Okay, now I will introduce some other rules of deduction. Okay, can I erase now? Is it okay? Any question? Okay. 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 Now, some rules. Some rules of deduction. Number 1. Modus ponens, like just now. So P implies Q and P implies Q. Okay, if you have P implies Q and then you have P, you conclude Q. Number 2. Just now we have contrapositive. P implies Q if and only if not Q implies not P. Number 3. Implication. P implies Q. There is a typo, yeah? If and only if, we have seen this before. What? Not P or Q. Not P or Q. Dekat nota tu ada not P or not Q, right? So you delete that one. Not P or Q. Okay. Number 4. Double negation. Meaning, not of not P, not of not P is P. I don't need to put the parenthesis, so it's okay if you don't put parenthesis, just not P. Okay, so this is P. Now, De Morgan's call it De Morgan's laws. Call it De Morgan's laws. We have not P and Q. This is not P or not Q. And part B, not P or Q, not P and not Q. Number 6, commutativity loss. Commutativity loss. We have 2 also. If you have P and Q, you can switch, yeah? Is Q and P. And the same thing with P or Q. Commute. Commute means P and Q is Q and P, P or Q and P. And last one is distributive loss. Distributive loss. But A, P and Q O R. Okay. And inside or outside. So it's P O R, P O R, N, and Q O R. Okay. Then another one, part B, last one. P O Q N R. Okay, so this is P and R, P and R, or Q and R. Okay, yang last tu bukan P ya, ada typo sikit. Yang last tu ada R, Q and R. Okay, now as I mentioned earlier, this is the first time that we convert the document to LaTeX. They type it using LaTeX, and sorry for the typos inside, but I will correct this once we do it in class. Okay, yang ini, you have seen it before, so there's nothing new. Maybe the word De Morgan's law is new, right? It's just when you have the negation outside. This is called the De Morgan's law. So you have to remember this when we said use commutativity laws, distributive law. Don't get confused. Yeah, students selalu sangat confused. We don't have associativity laws because associativity says this is P and Q and R is the same as P and Q and R. So we just assume that we don't need to use parentheses. Tak berubah kan? So that's why we don't have this. The rest you have to know because there is a rule. Yeah? Associativity, don't worry about it. So commutativity and distributive. Okay, can I erase? Okay? All right. Now, we have to look at some more examples. Some more examples. Another typo sikit kat page ni, but I will write the right one. Page 63. Example 4.5. Show that not Q and R imply S implies SOQ and SOR. Show that for all Q and R, show that not Q and R imply S implies SOQ and SOR. You can do this also by showing it's a tautology, but this asks us to use argument, okay? To use argument and use rule of deduction. So if you show using table, you won't get any marks, okay? Unless the question asks you again the second part, use the truth table and to show this is a tautology. Then you can use a truth table. Okay. Now I will write as 1, 2, 3, yeah? So just write the question. Not Q and R implies S. Okay, you see this one has no implication. So we will use the fact that apa formula dia? P implies Q is the same as, I can write like this or I can write like this, not P or Q. Okay, not P or Q. P implies Q is not P or Q, but not P is already not, right? So not, you just have Q and R or S, right? P implies Q is not P or Q. Not, but P already has a not, so not cancel, so just Q and R or Q or S. Okay. Now, distributive law. Can you continue? Okay, so what does it mean? This is QoS, right? QoS and ROS. Then you write this 3 bits. Is it similar to this? Not yet, right? So this is S or Q and SOR. Then Comeo 30 blocks. Then you just put ... so that can see therefore. Okay, therefore. We take a 5-minute break, right? 5-minute break. All right, we continue. Okay, with example. Right, example 4.6. Are you still here? Cijian dah tukar rupa dah. Macam-macam ada You explore Kat mana you all explore ni? Oh, choose avatar. Stop video. Ada arrow ke atas tu, kat tepi stop video. Ada video filter. Ada avatar. Apa lagi ada? Video filter jadi apa? Oh, ada itu Okay. That's cute. Oh. Grab pula. Ish, main-main lah you all ni. Okay. Show that. Okay, this is the question, yeah? P if and only if Q and Q and R imply S. Okay, satu lagi yang besar. P if and only if Q and R imply S imply P and R imply S. Oh, ini guys, if you have change, if you move, oh, bergerak juga ya. Okay. Try to do like this. Is it? Oh, okay. As long as I can see you move. Yes or no. Okay. P implies, okay. If you given in, tapi, yeah, kalau final kan, you are given a question and you rewrite in your book. Make sure it is right. If you copy it wrong, the whole thing will be wrong. Dah banyak sangat berlaku. Okay, because not or all those things. So make sure you double check. Let me double check. And Q and R imply S, P and R imply S. Is a tautology. This is using arguments, yeah? This is using arguments. If you use truth table, it will be quite long. You have P, Q, R, S. So that will be 4. 2 to the 4 will be 16. 16 rows. That is too long. Okay. So, right. Now this is the premises. And this. Okay. This and this imply this. Right. Kena tenang dulu. You have to really look at the question and see what happened. Okay. We have this. So number 1, P if and only if Q. Okay. Number 2, Q and R imply S. What do you want? You want P and R imply S. P and R imply S. But P and Q, they are if and only if. So, from 1, you substitute in here, P and R imply S. from 1 and 2. Dot, dot, dot. Then you are done. Yeah. You have to really look at the question and what do we want to show. I repeat, first, P if and only if Q. Whenever you see P, whenever you see Q, they are the same. Next, you have Q and R imply S. What do you want to show? P and R imply S is very similar, just that Q is replaced with P. But Q can be replaced with P. So you copy the first one here, then you copy the second one here, and then from 1 and replace into, you get already this one. Then you just put therefore, dot, dot, dot. Okay. Alright. Macam chipmunk lah, eh. Okay, now we want to look at the next one. The next one is, saya padam, eh? Okay? Kalau okay tu, okay is a magic word. So you go to apa tadi? Reaction, ya? That one, ya? Okay. Padam ni lah dapat first line. Okay. I think you can still see if I write here. Okay. Now this is 4.3. Abbreviation and extension rules. P and Q implies P. You can just choose one. Is an abbreviation. /1. If you have P and Q/1, just take P, just take Q. Okay. But if you have just P, you can add, but you put or, because P is already true. Whatever you put inside with the or doesn't matter, right? Because it will still be true. Is an extension. Okay. Example 4.7. Prove that the argument is P implies Q, P and R, Q and R, P implies Q, P and R, so Q and R is a valid argument. It's a valid argument. Okay. Now, number 1. Number 1, P imply Q. Okay. Number 2, P and R. Okay, P and R. We want Q and R. If we want Q and R, we need a Q, we need an R, right? We need a Q, we need an R. How do we get R? We get R from here, right? We get R from here. How do we get Q? We get Q from here. Okay, this is the one that is given. Now, from P and Q, you can get P. So from P and R, you get P. So 2 and abbreviation. Right? From 2, you get 2 and abbreviation. Then from 1 and 3, 1 and 3 and modus ponens, right? 1 and 3 and modus ponens give you Q. Right? If you remember just now, modus ponens says if you have this and then you have this, you will get Q. Right? So I have number 1, I have number 3, and with modus ponens, I can get the Q. Now we get Q. What about R? R. How do I get R? R is from 2 and abbreviation. Okay, last one is, therefore, Q and R. I have Q, I have R, Q and R. You see, this is not abbreviation or extension because we have both are true, then you can just add. Yeah. So this is from 4 and 5. 4 and 5. Is it clear? Yes or no? Yes. Okay. Let's try number 4.8. I give you 5 minutes. 4.8 and 4.9. 4.8 and 4.9. Okay. P and P or Q implies R is tautology. I don't see your handwriting. Okay, anyone wants to share? Kat bawah tu ada share screen. If you want to share, you can just press. Anyone want to show? Yours mungkin canggih-canggih. You can use. If you have tab. Okay, anyway, let me see. Number 1. Okay, P, right? Because there is a P, so you put P. Number 2, there is an N, so you copy this one. P or Q implies R. Tak ada, ni pun tak apa. Just that. P or Q implies R. You want R. So you know already the answer. You know already the answer. Okay. How do you get R? You need to have P or Q. But from 1, extension, right? Extension from 1 and extension. If you have P, you can add whatever it is. P or Q, P or R. But I need P or Q, so you can use modus ponens. Okay, so already number 4. Oh, so you have this, so you have R. This is from 2 and 3 and modus ponens. Magic. So you have R. Okay. Dah nampak jawapan okey lah kan? Okay? Okay, can I erase? I will wait until you say it is okay. Any question, guys? Is it okay now? Yes? Okay. Now we go to 4.9. 4.9. Prove that the statement, okay, below is a tautology. Okay, so this is P implies Q. P implies Q and P and R. P implies Q and P and R. And R imply S. Implies, okay, need one more here. Implies Q and S. Okay. P implies Q and P and R, and R imply S, imply Q and S. Okay. Apa-apa pun kita tulis dulu. What we have? We have P imply Q, and then we have P and R. Okay, and then we have R imply S. Okay. Now what we want, saya tulis kat bawah dulu What we want is Q and S. So I need a Q and I need an S. right? I need a Q and I need an S. From here, I get a Q. From here, I can get S, right? So the steps are not unique. Mungkin kawan awak buat ni dulu, awak buat ni dulu, but it's okay as long as it's all there. Yeah, your number 3, 4, 5 might not be the same with the others. You can do this first. Okay, do later. Okay, so I need Q. So from this, I have P. So this is from 2 and from 2 and abbreviation. From 2, I can get P or I can get R. Why do I need P? Because from 1 and 4 and modus ponens, right? From 1 and 4, because I already get P implies Q and then I get P, so I can get Q. So I can get Q. Now I need an S. To have S, I need R. Tulis ke bawah sikit. Okay, so I need what do I need? R. Okay, I need R from 2 and abbreviation. Why do I need R? Because I need S. How do I get S? From here. So I need the R. Okay. Now, not yet, yeah? Not yet. So R imply S and R, I have S. Okay, so this is from 3 and 6 and modus ponens. Now, I already get Q, I already get S. So from this and this. This is actually we call conjunction, just conjunction. Because true and true is true. Okay. That's Q and S. Q and S. Tadi saya kata it's not unique because you can do P and then you can do R first. So ni boleh switch. Ni boleh switch. Doesn't matter. Yeah. Okay. Any question? Ismail? Okay. Saya dah share screen ni. Susah sikit nak baca chat. You can
Doktor.
Yeah.
So nanti kalau dalam exam kan, contoh kalau dia keluar soalan macam ni, kita kena hafal ke yang abbreviation tu? Dengan extension apa semua tu?
Tu yang saya kata kalau final, dululah pernah dibagi list of all this. Kalau test, nanti saya confirmkan. Kalau tidak, kena hafal lah. Tapi selalunya nak gunakan yang simple-simple aja. Modus ponens, abbreviation, itu je selalunya lah. Tapi kalau dah banyak-banyak, kan yang tadi tu just distributive. Tapi saya akan confirmkan. If they didn't give you, then kena hafal lah. Alright? Okay ya? Saya padam boleh? Okay. Alright. If you do exercises, keep doing it, boleh terhafal lah. Okay. Modus ponens is the normal one. Modus ponens. Okay. So, kita ada lagi ke? Example. I think we did all, ya? Okay. Tapi selepas ni, susah sikit nak hafal. Saya pun kadang-kadang Confuse juga nama dia. Nanti saya discuss dengan penyelaras. Penyelaras sila Dr. Noor. Dr. Moin ya. Okay. So we go to 4.4. More rules of deductions. More rules of deduction. 4.4.1. Disjunctive syllogism. Okay? Walaupun tak ingat nama, but if you remember what it is pun sebenarnya okay. Saya tulis inilah. P or Q and not Q. Logik dia if you have P or Q but you don't have a Q. You have P or Q but you don't have a Q, it must be P. Macam tu. Or kan salah satu atau kedua-duanya, but one is not there anymore, you have to take another one. So that is what it means. The same thing as if you have P or Q, but you don't have a P. You don't have a P, you have to have the Q. Okay. Now, example. Example 4. Prove that the argument B implies A, not A, B or D, hence D below is valid. Ini pun satu cara menulis soalan lah. Okay, prove that the argument below is valid. B implies A, not A, B or D, hence D. Okay, cuba try test. Okay. So, 1. B implies A. Salin soalan pun dapat markah. Not A. B or D. B implies A, not A, B or D, dot, 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 D. Ah. Nampak tak? Nampak? Nampak tak jawapan dia? Let me see. Suhaila. Suhaila, janganlah pakai macam tu. Saya tak nampak lah muka awak gini ke, berkerut ke. Saya nampak Suhaila, Saiful, Zizian. You okay tadi. Nampak tak? Nampak tak jalan keluar? Okay, you see? What do you see? I see kontrapositif kan? So, from 1 and contrapositive because there is not A, right? There is not A, so it's not B. So not A implies not B. Because from 1 and 2, I have not A, right? Contrapositive. Okay, so from 2 and 4 and modus ponens, right? From 2 and 4 from modus ponens, which is not A, then not A implies not B. I have not B. Okay, so kalau not B apa? Not B apa? From here, I have B or D, but I have not B, right? So dot 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 D lah. So this is from 3 and 5 and disjunctive syllogism. The conjunction, conjunctive, disjunction, disjunctive, right? So from this and this macam ni lah. Ni, non kan? From this and this I got D. Dah dapat dah. So this actually easy in a way that you are already given the answer. Just how you get to the answer. Okay? Saya pergi sangat slow hari ini. Okay? Okay? Until later if we have time, we do the exercise. But let me go through with this section first. There's still a few more. It's quite long. Okay. Next. Boleh padam ya? It's okay. Yes. I erase ya. Okay. 4.4.2. Hypothetical syllogism. Hypothetical syllogism. P implies Q. Q implies R. Therefore, P implies R. Before this, when we see this, we call it transitivity, right? Transitive kan? Under the deduction reasoning, under these arguments, we call this hypothetical syllogism. If P implies Q, Q implies R, then P implies R. P implies Q, this Q implies R, so P implies R. Okay. Now, there is an example there. If the sun shines, then the day is bright. If the sun shines, then the day is bright. If the day is bright, then I am happy. If the day is bright, then I am happy. Therefore, if the sun shines, then I am happy. Okay. Now, let's try this. Example 4.11. Prove that A implies not B and C, B or D, A implies D. Is a valid argument. A implies not B and C, and then B or D implies A implies D. Okay. Number one, A implies not B and C. A, not B and C. A implies not B and C. Number two, B or D. And then we have to show A implies D. Okay. I give you 2 minutes to think. Depends, 2 minutes to think. Ada yang dapat tak? It's very hard actually because there's a typo. Sorry about this. This is O ya. Oh, patutlah tak dapat. Okay. But this is hard. This is quite hard and tricky. Okay. Kita nak guna tu. P implies Q, Q implies R. So if we have A imply this, and then somehow we have this implies D, then you have A implies D, right? So I actually want this to be this. Betul? This to be this. But how do I get this in terms of implication? Okay, so you remember this? Right? Now we want to go back. Okay, so if we have B or D, oh, kesada. So this is supposed to be not B implies D. Right? So the B is not P. So not P, which is P is not B. Not B. P is not B because B is not P. So from here, I can have not B implies D. Okay? From 2. Okay, from 2. Tapi mana sama ni dengan ni? So this is why I need an or. Dalam soalan dia, not an, or. Okay? Because number 4, I can introduce. I can introduce yang tadi tu. Extension, right? And extension. Instead of not B, I can have not B or C. Kenapa saya nak ni? Sebab nak sama dengan ni. Right? Now you have A implies this. The same thing implies D. So, A implies D. Right? This is from 1, 4, and hypothetical syllogism. Okay. 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 After this, you read through example, because we don't have much time. Example 4.12, yeah? Example 4.12, the answer would be yes, yes, and no. Example 4.12, number 1 is yes, number 2 is yes, number 3 is no. Number 3 is no because of the N at the end. Then you have to go to example 4.13. Okay, 4.13, you can read through. Then you can go example 4.14. Then you can read through. Okay. Let me just list first. Then we will continue next week, yeah? Kami start dia ni. Let me just give you first 3 more. 3 more and explain. Then you can see the example yourself. Cepat sangat masa berlalu ni. Sekejap aja dah nak 2 jam. Okay, let me see. 4.4.3. Contradiction. Okay. Okay, number 1. Not B. R and not R. Implies P. Okay. Why? This is always false, right? If this is true, this is not true. This is true, this is false, and has to be always false. All right? Okay, so this is always false. Suppose P is true. Suppose P is true. If P is true, not P is false. This is always false. If P is true, not P is false. Then false implies false is true. P is true, so true meaning P. If P is false, not P is true, so true implies false is false. And this is also P. This is what it means. But this is very rare. We don't normally use this. But in case you need to use, so if it is not P and something is not true, you will get the opposite of this. The opposite. This is always false. So we have always false. If P is true, not P is false, becomes true, which is the opposite, the P. Yeah, the P. And P is false, the not P is true, implies false is false, which is exactly P. So this is what it means by this implies P. Okay. The second one, P and not Q, and R and not R implies P implies Q. Okay, so this is always false, right? This is always false. So something with false and is always false, right? This is always false. So false implies whatever it is always true, right? So it doesn't matter. Okay, so that's it for this. The next one, this one you don't need to memorize actually. It just give you, you will be given this if you have to show it's true. 4.4.4 absorption. Okay, absorption. P implies Q implies P implies P and Q. Ni pun penting this is important. If you have P implies Q, you can absorb P inside. So P implies P and Q. Okay. Actually, the example after that show why this is true. And example 4.16 show you one example. Next one is constructive dilemma. Aha. Okay. This is nama pun dilema, betul? P implies Q, P implies Q, and R implies S, and P O R. P implies Q, and R implies S. There are four different one, yeah? Four different one. And then we have P O R. P O R. This says, this gives P O R, this gives Q O S. Aha.